Welcome, everybody. We're so glad you could all be here. Welcome to the Emerging Media Labs 2022 Annual Winter Showcase. Today, we'll be showcasing a lot of the projects we've been working on throughout the terms. Thank you all for joining us in this busy time. We know it's a little crazy with exams and everything. So special shout out to our project teams for getting everything in on time while juggling exams and work, et cetera, et cetera. My name's Matt. I think I know everybody here. I'm the new lab coordinator at EML. Well, new, it's been almost a full term at this point, which is insane. It's an honor to be with you guys this afternoon, and I'm looking forward to guiding you through this exciting presentation we have. Before we begin, I'd like to acknowledge that UBC Vancouver is located on the traditional, ancestral, and unceded territory of the Musqueam people. The land is situated on has always been a place of learning for the Musqueam, who for millennia have passed on their culture, history, and traditions from one generation to the next on this site. Now I'd like to go through some important housekeeping points before we begin to dive into our presentations. So firstly, the event is being live streamed on YouTube and recorded to be posted on our YouTube later, so please keep that in mind. And we're also going to be doing questions a little bit differently. This is something we sort of did last time, but since it's internal and small, we think it would be better to just talk to the teams yourselves in the demo section if you have any questions, because you'd be able to get much more of a one-on-one experience. So if you have any questions, please keep them in mind and save them until the end. And yeah, if you were online joining us on YouTube for the live stream, feel free to put the questions in the chat, and then we will have them answered at the very end as well. And lastly, please ensure your cell phones are turned off and put away so there are no interruptions. So now let's begin our project presentations. Today, we'll be hearing from the teams of Moot Court Cognitive Systems 300 Labs, 3D Metabolism, and 3 of the Theater 399E projects, the Emerging Media Lab Tapestry, Remote Virtual Production Interaction Prototyping, and UBC VR Paintball Experience. First up, we have Moot Court. So I will pass over the mic to the student speakers, Juno and Michelle.
Thank you, Matt. Hello, everyone. Thank you for joining us today. Before we present our development for this term, I'll do a short introduction and provide some background information about Moot Court. So Moot Court is an online tool designed to help law students with their psychologically terrible first-time Moot Court experience. So what this is that, as of my knowledge, since I'm not a law student, as a law student, this is the first time where you actually go to an actual court and present your case in front of an actual judge. So our application is used to help them by replicating the scenarios and by presenting their case to the virtual judges. So for our development team this year, we have Rosalind Beck as our team lead. We have Michelle Hyun and Juno Yoon as the software developer, and we have Jenna Arianto as our designer. So this year, we had an opportunity to test our application in the Think Forward UBC alumni event. It was exciting to see how this application was used by the participants, which provided invaluable opportunities to receive feedbacks and recommendations from a wide range of audiences. Based on the feedbacks received and the internal reviews conducted, these are the main issues that have been addressed during this term: debugging, reworking the code base for long-term scalability, and making improvements to the UI. We restructured the application code base and made it more robust by migrating it to TypeScript and using linter for consistent code style. As we reorganized the code base, we improved the application and optimized the voice and by modifying the original code. We have also implemented a loading screen and a detailed documentation for future iteration of this project. Although rewriting the code base was a large developmental task, we decided to do so due to the lack of long-term usage and viability of the existing code base. Due to its limited reusability and deprecated features, we believed that building upon it would create a severe developmental overhead in the future when working on implementing user interactions and additional features like video recording. Limited reusability includes the lack of proper documentation to assist codebase navigation and method triggering, and deprecated codebase was mostly due to dependency on old packages, which contributed to the lower resolution of our assets. Here are some of the improvements that we have introduced to the codebase. First, in the folder structure, in the original version, all components used were stored in a single components folder. This made it very difficult to assess which similar functionalities have already been implemented and what scripts were being referenced by other scripts and what general functionalities we have created for the application. By introducing the nested folder structure, we can now clearly see which features exist in the code base and where we can look to find past examples of a feature that we wish to create. There have been some restructuring of the code base as well. Before, the code base was quite bloated. For example, in the avatar.js script, all functions pertaining to the voice and animation components of an avatar were mixed, and it was difficult to understand how each function was being triggered or affected the entire application. We mitigated this by creating voice and animation subcomponents, which are returned by the avatar.js. Now I'll pass it on to Michelle to discuss the UI improvements and the debugging.
Thank you, Juno, for that wonderful explanation. So this semester, some of the things that we did was make improvements to the overall code. In particular, we had to fix some ongoing bugs that were in the previous build. In particular, we noticed that when judges were being swapped with the skins, there will be an overlap with multiple models being loaded at the same time. In addition, there was a bug where the timer will be visually paused, but the judge will keep talking, which is not the intended purpose. So to solve these bugs, we decided that a global timer is necessary in order to keep track of all time-related functions. And so to do this, we had to implement the global timer and have clear documentation for future developers in order to keep track of these changes. In addition, we made some changes to the UI. So one of the things that we noticed was that UI was not very intuitive and is quite intimidating for first-time users because they do not know which features will be implemented within the actual application, since not all of the features listed on the page were actually functional at the moment. And thus, the solution was to create a simpler UI so the user doesn't have to think too much and it's more intuitive for them upon sight. So here is an initial layout of the very first moot court. As you can see, it's pretty simple at the beginning, and then it gradually gets more complicated as the user progresses. So they have essentially 3 to 4 pages of stuff before they can get to the actual content itself. If you want to try out this implementation, you can go to ubcmootpractice.ca. So this semester, we implemented a newer version of the moot court and tested it out during the event mentioned previously. So at very load, upon load, they would be greeted with a judge who will tell them to choose their position. This also had the benefit of time-triggered events and manual events where someone can press the key to have the judge speak immediately. In addition, we improved the menu navigation by having the users go through less options in order to customize the features that they intend to customize. The prototype can be seen through the Figma file below. All the changes that were mentioned for the UI were done with the following principles in mind: making the experience seamless and engaging and simple, and emphasizing the customizability and accessibility early on, while also aligning to the UBC Allard and EML branding guidelines. And so while we are currently at the testing process, we believe this to be a pretty successful launch of January's January's version of Moot Court, which will be tested in courses.
So for the future development for next year, we are planning to deploy our application and perform user testing of the new UI and our added functionalities. Then we would also like to improve the 3D modeling of the avatars and implement interactive animations. Since the user desired to have account interactions and management, along with the feature to record the video, we decided to introduce databases to manage user accounts. Thank you for listening to our presentation, and please let me know if you have any questions.
Thank you so much to Moot Court. Next up, we have EML's newest project, Cognitive Systems 300 Labs, and I would like to hand it over to the team now to present.
Thank you so much, Matt. And I wanted to thank everyone who has come here today, and I want to also thank the COGS 300 team as we present to you today. So this is COGS 300 Labs, and this is the Cognitive Systems 300 course in the Cognitive Systems program. And I want you all to take a moment to think of how you got here today. Maybe if you're on YouTube, you had some sort of algorithm to find a link in your email, or maybe if you're here today, you took some steps to walk into IKB. So this is what this is all about. It's figuring out how we and artificial agents navigate environments. Cognitive Systems as a program combines computer science, psychology, philosophy, and linguistics in order to understand and design these sorts of cognitive systems. So a little bit about the project and sort of how it came to be. We have our lovely team here. Me, Ray, we have Elaine, Reed, and Beth. We also have Reva and Tanya. We've got Kyle Squared, and I want to give a thank you to Daniel and Robert. And Martin will give a little bit of background.
Martin Shorshkuti, and I'm an associate professor in the Department of Linguistics at UBC. One of the courses that I teach is COGS 300, or Understanding and Designing Cognitive Systems, which is one of the core requirements of the Cognitive Systems undergraduate program. It's a really fun and rewarding course to teach with kind of an interdisciplinary approach to cognition. And one of the key parts of this course is the labs. Traditionally, the labs used to focus on building physical robots, but because of COVID, we were no longer able to do that. So we had to transition to a different type of lab where they do something similar, develop virtual agents, kind of like robots, but now in the Unity 3D environment. Because we had to do this in response to COVID, we couldn't put as much work and thought into these labs as we would have liked to. But they did end up being very successful, and the students liked them. We still felt that there was a bit more work to be done, so we invited EML to basically do this exploratory, very cool project with us where we rethink how these labs could be done and redesign them. The ML team is now going to tell you about all of the cool things that they've come up with and that they've implemented. I would like to thank them for all their work this term. And yeah, let's hear about the project from them.
Thank you so much, Martin. And as he mentioned, there are tons of cool things, and as this is a bit of an exploratory project, we broke this down into a few different branches, which my team will talk about today. So we start with the user research. We also have instructions. We've got lab visuals, pedagogy, lab functionality, and coding supports. So I will kick it off to Tanya to talk about user research and instructions.
Thank you, Ray. Hello, my name is Tanya, if you hadn't already gathered. So why user research? User research because it is the most fundamental element of the design process. We want to understand what our users' needs are and how we can solve them. So that was the first step in understanding and designing for this exploratory project that we're undertaking this semester. So our user research focused on key 3 users. We had the principal investigator, Martin, who you saw earlier. We had the TAs, and that makes up the teaching portion of the COGS 300 course because it's important to understand their experience as well. And then we moved on to our key user, who are the students. So the students, both old students and current students, we interviewed. Using user interviews, we also conducted observational fieldwork by going into the labs and asking the students what they liked about the labs and what they thought they could be improved. So some of the insights that we gathered, I'll start with the positive ones because we always give bad news first, but let's give good news first. So the good news, Lab 3, which was the Fireflies lab, was the most popular lab. And this really embodies the COGS concept of synchronization, and students really saw it in the lab. The other thing they really liked was being able to have applicable skills like learning C# and Unity. But on the downside, coding, it's really hard, especially C#. For students that have never coded before, not only do they have to understand Unity, which is a pain to run on a 2015 MacBook, which is what I used when I took the course. And there are a lot of technical difficulties with the software, but also with the coding. And another thing that we didn't even think about was the instructions. The instructions weren't clear enough. You think, hey, here are the steps, go do it. It's not enough. Students need more, and we wanted to give them more. So the action items were to clarify the instructions, make them easy to digest so students understood what they were doing, providing code support, and strengthening the concept to code pipeline. So I will talk a little bit more about the instructions. So there were 3 types of instructions for each of the labs. There were the pre-lab instructions, the actual lab instructions, and the post-lab instructions. So the pre-lab and the post-lab were both on Canvas under the course homepage, but the actual lab instructions were on the UBC blogs. And what we wanted to do as a way to organize the course better was consolidate all of the information onto a single software and program. So we created lab templates in Canvas for each of the labs, and using the module function, we grouped them really nicely. So that way the information is all organized for the students to have in the same place. Another thing we did was clarify the actual content. So we did this by breaking down the steps even more, and more importantly, adding learning goals to the top of the lab so they understood what they would take away. We also did this neat thing where we incorporated a story element. So all of that combined makes the labs really easy to digest, and it really makes the students understand what they're doing. And the cherry on top was the visual elements, because we love looking at pretty things. And that's everything to do with instructions. I will give it now to Reva.
Thank you so much, Tanya, for that. I'm now going to talk about the visual elements of the labs. In order to make the labs more engaging and help the students learn better, we decided to redesign the visual elements of each lab and also kind of incorporate, like as Tanya said, a more narrative structure. We did this by having the core theme loosely follow the plot of a single soul following different robot bodies, exploring the world of artificial intelligence through each lab. And this was done, we implemented this by having the robot characters and the environment of each lab evolve over the course of the labs. So it starts from the earlier labs with a more simple antique mechanical design for labs exploring topics such as simple hard-coded logic, but in the later labs, they have a more futuristic and modern design in the robot and environment for the labs that explore more complex concepts such as embodied cognition. And we did this, as for the softwares we used to redesign the labs, we designed the characters and environment on Blender and imported them into Unity, and also used assets from the Unity asset store such as skyboxes. And all of them together, we kind of redesigned the entire look and visual element of the lab. I will now pass it over to Reed for the structure and functionality.
Thank you very much, Reva. So one of our primary concerns with the lab content revolved around the pedagogy of how we were going to communicate these course concepts to students. So in the course of the user research, we found that there were 3 primary areas within each lab that was causing issues. The first was that students felt like they were really rushed. They just didn't have enough time to complete the labs. And part of this is because labs themselves really focused in on the technical content. And this created a situation where the computer science students that were part of COGS really enjoyed themselves and had a great time. But the other students from other disciplines really felt like they couldn't contribute to the team as much. So our solutions on this, we wanted to create labs which encouraged more exploration and experimentation rather than focusing on the technical problem solving. And this really allows us to model and to demonstrate course concepts in a more accessible and interactive manner. And the hope is that this will help foster interdisciplinary communication amongst the teams and within the lab groups. So how did we actually do this? How did we implement these pedagogical approaches? There are 9 full labs in this course, but this term we focused in our efforts on 3 of the labs which we felt like we could improve most. So Lab 2 here focuses on teaching students symbolic approaches to creating intelligent agents. In the previous Lab 2, students gave 3D rotation instructions to an arm, but this was confusing for them and it didn't really relate to course theory, so we simplified this to self-driving cars instead. In the first section, the agent executes a list of predetermined instructions, one at a time, kind of like a Turing machine. And in the second section, we gave it some distance sensors, and then you use logic to figure out which way you want it to turn. In Lab 3, students investigate emergence, and this is where simple behaviors can combine into something that is more than the sum of their parts. So in the previous version of this lab, students simulated real fireflies who synchronized the flashing of their lights, and this was one of the students' favorite labs. So we kept this same algorithm, but we made it much more performant so that we could simulate several hundred fireflies instead of the less than 10 that we were restricted to before. And then we also added in animations and flocking behavior, which helped the students replicate the movements of a firefly swarm, which is also an emergent behavior. In Lab 6, students learn about embodied cognition, and embodied cognition is where we switch from viewing the brain as the seat of intelligence and instead emphasize how our bodily senses and actions can determine our behavior. So in the past year, students programmed different types of bodies, different types of robots, and they all kind of navigated a little bit of a maze in different ways. But this time we wanted to take a more direct inspiration from the course content. So the first example here just shows an agent that navigates by directly mapping sensor distances to motor movements. And then in the second example of the Dynabots, we actually were inspired by class content and a paper with the same name, where these bots use that same sensor mapping algorithm, but what they do is, in avoiding the obstacles, they can see to the sides but not in front of them. So they avoid the edges of the arena and push towards the center, but they can't see what's in front of them, so they can't see the blocks. And what you get is this really neat tidying behavior, actually, where they go and collect the boxes from the edges and push them all towards the sensor. And the algorithm for doing this is basically just look at your distances and turn the difference between them. It's very simple. So our overview on this is, with the 3 labs that we implemented the new code for, we were successful at making them more experimental as well as exploration-based. We were able to create stronger connections to class content, and we are able to make them more accessible and more interdisciplinary to reflect the audience of COGS students. And for our next steps, we're hoping to integrate our code with the lovely work that our designer team has done. And we want to continue work on creating and testing the new instructions for these new labs. And we want to spend more time going through the same process with the other 6 labs in the course. And I will pass it over to Elaine.
Okay, thank you, Reed. Right, so coding support is a fundamental part of a project because it really supports our idea of wanting the students to have a good experience in this lab. Other than the visuals and the designs of the lab, a smooth experience in completing the objectives that the lab poses would surely improve the overall experience of the students as well. So as the information gathered by our user research team and other lab members, we have identified the problem with how the labs were was that it was heavily technical and skewed towards the computer science aspect. And so in addition to changing the lab design, we also want to provide additional supports. So here are the coding supports. We have reached the conclusion that we would benefit from a Unity and C# reference sheet for the students, so that they could reference and not be intimidated by the new technology and the coding. And also, because thinking of the course objective is to let the students think about how robots think, how robots learn, and the cognition aspect of things, we really don't want the students to be stressing over Unity and C#. So in our reference sheets, we provided as much support as possible to the technical side. So we covered the Unity setup and the terminology and the layouts. For example, we would introduce the definition of a game object and the components of the game objects so that the students can get an understanding of what they are, what they mean, and how they relate to the game that and the objectives that they're trying to complete. In the C# cheat sheet, we have defined the terminology such as if statements and for loops and things like that would help them in completing the coding aspect of the lab. With these tools in hand, we really hope the students to take an explorative approach and to try things out and not feel stressed out by not knowing these things. We've made a visually appealing a slide that we hope to print out and have the students easily reference while they're performing the lab, so that we really want them to have a smooth experience with the coding. We will continue to improve on the student supports in the coding aspects and have the students have a good experience in the lab overall. Okay.
Awesome. Thank you so much. Thank you to my team for explaining all the different aspects of this project, from user research to the instructions, to the lab visuals, the pedagogy, the lab functionality, and of course, coding supports. This is such an incredible project that allows both us as EML people, but also the cognitive systems students to sort of explore what it means to be an intelligent agent and explore the environment, so to speak, of artificial intelligence and what it means to be in a body, in a space with other people doing cool things. So I wanted to thank you so much for listening. And yeah, I hope you enjoy navigating the world.
Great job. Thank you so much to the COGS team. It's really exciting to see a new project at EML, and we love that it's coming to fruition. Now we will hear from our 3D metabolism team. It was a bit of a unique presentation, so come on up.
And then, so I guess we're going to switch to this live demo, and we'll just leave the slides in a sec. I missed that. Hold on. Okay. Do I need, is this the slide advancer? Thanks. Okay, so I'm from biochemistry and molecular biology, and 3D metabolism is a project that aims to effectively visualize cellular metabolism in sort of an immersive, interactive 3D space. So for some of you that aren't biochemists, really simply we define metabolism as sort of the entire collection of chemical reactions that occur in a cell or an organism. So of course, if we view biology at this sort of molecular level, metabolism is really complex. And it's also, and it forms this complex network, and this network is also dynamic because the compounds or the molecules that a cell makes or consumes depends on sort of the environment that that cell experiences, or sort of the physiology around that cell. And so we're trying to build a network that effectively and visualize metabolism and sort of effectively visualize this complexity, but also the dynamics that occur in this network. And we're hoping to do that to support learning metabolism in undergraduate courses and also in other learning environments. But we're also hoping that this project will support research fields that relate to metabolism, so studying metabolic diseases or fields such as metabolomics. And sort of the two primary things that we've been working on with this project, one, we've been developing a network in Unity, and this network consists of a collection of nodes and edges that are interconnected. And we've also built a wiki base, which is a database that contains a lot of chemical and metabolism data that is then called to the Unity platform to enable a lot of the functions within our network. So our team has decided to do a live demo today, which we haven't done in the past, but we thought it would be nice for the audience at Showcase to actually see what we've built. So first, Tom is gonna provide a demo of the Unity, the platform, the metabolic network in Unity, and then after that, Ryan is gonna provide a demo of the wiki base. So I think yeah. Do we need to bring up that, I think? Yeah, leave the slides. Right now. All right, thanks.
All right, thank you very much, Lindsay, for that introduction. I think, let me just find my mouse cursor first of all, and then, why is it not showing? Do I need to drag it? Oh, okay. Okay. There we go. Okay. All right. So, what are we looking at? Let me just turn off all of the labels first of all, so that it's not so confusing. We are looking at, as Lindsay has told us once, a collection of reactions within that occurs within the cell. You can see some of the reactions leading and occurring outside of the mitochondria, and some of them occurring inside the mitochondria. And we might be wondering what each of the nodes are. These are metabolites. If we hover our mouse over it, we can see the little labels. This is glucose, one of the most familiar ones we would come across. And if we click on it, if I can just get my mouse on top of it, there it is. We can see the sidecard that shows all the good information, and also an interactive compound visualizer for glucose. I'm not sure if it's fully correct, but I think it is. And aside from this feature, we can look at every individual pathway. Maybe the first pathway that you will learn as you learn about metabolic pathways is glycolysis. And we can once again turn on the labels so that we can see all the nodes. And this might be a bit overcrowded, so we can change the label filter to highlight so that we only see the nodes of the highlighted pathway. And as your learning progresses, as you come to learn more pathways, you might want to know all the pathways related to glucose, so you can highlight multiple pathways, glycolysis, gluconeogenesis, and glycogen synthesis, for example, and look at all of these pathways and explore them as a subset of all the pathways in this network. And on top of that, one thing that's interesting is that glycolysis and gluconeogenesis have a lot of overlap, and we can use the double highlight feature to compare the difference between two pathways like this. And these are the main features in the main network that we're showing off. And over this term, we are also looking into some more additional features. One of the things that some of you might have noticed is that some of the nodes are connected to other nodes that are outside of the glycolysis pathway. And so this feature gives us the ability to search if there is a pathway that exists between two nodes. I'll just give a quick demo, left and right. Okay, so glucose, and yeah, this is a bit clumsy. Lactate. And let's see if there's a pathway. Oh, there is. And it highlights the pathway between the two. There is still a bit of a bug in this. As you see, this is not fully leading into lactate, but visually, this is what it's supposed to do. Finally, I think you can see that there is a lot of information that is being presented in this app. So how do we find a good pipeline for the content team, for the people who know about these information to populate the entries in a database, and how can we query the database and populate those information into this 3D app? What we settled on was Wikibase, and we will have Ryan to tell us about how Wikibase is set up and what it looks like. All right, let me just switch back to the slides if I can. There it is. Can you help? Yeah. Thank you.
Thanks, Tom. I don't think that's our database. No, wait. No, wait, I don't think that's the database.
Do you have the link on? Do you have the link on the demo page? That's fine. That's fine. Can you just talk about it?
Unfortunately, we are not able to display the database, but I'll give a quick overview of the database. So our database looks similar to this. This runs like Wikipedia, and it's an open source database where we have all our information stored that has additional information from the network, plus all the information that is found on the network. Similar to Wikipedia, we have organized it into 4 sections. So it has a pathway page, a reactions page, a nodes page, and an edges page. The pathways page has all the reactions that take place in a cell. So for example, glycolysis, the urea cycle, the TCA cycle. For the purpose of this presentation, I'll talk more about glycolysis. So when you click into glycolysis on our database, we have a bunch of reactions that pop up, plus another descriptory property at the side that says, okay, what type of reaction is this? So in that sense, it would be Haspart. Once you click into a reaction such as glucose goes to glucose 6-phosphate, which is the first reaction of glycolysis, you're presented with another page which has a label of the pathway. So in that sense, it would be glucose goes to glucose 6-phosphate. You would have the description, what exactly happens in that reaction. And then at the bottom of the page, you would have any additional information such as what metabolites are involved, the enzymes, the energy required, and any other additional links that a student may need to be successful in that class would be listed on that page. And then the final page in that database would be the nodes page. So if you click into glucose, you would find all the information pertaining to glucose, such as the chemical structure, any additional links, the charge of the molecule. So in this sense, glucose would have a charge of 0, would be listed on that page. Thank you, and I'll pass it on to Lindsay, who will talk about the further directions for this project.
Okay, hopefully you enjoyed the live demo. So a lot of the work, I think at the beginning of the presentation, I said that the sort of 2 big tasks that we had for this project. One was managing complexity, because a metabolic network is a very complex network and there's a lot of information. And so we've been really trying to build this network in a way that enables the user to manage complexity and sort of turn various features on and off and view chemical detail, but not all at once. And so we have some additional kind of work to do there. We'd like to add some sub-reactants and sub-products and sort of expand the network a little bit more to kind of represent at least all of the kind of central metabolic pathways. I'd say we're about sort of 80% there, 75, 80% there. But the next kind of big step that we want to make on the network is really being able to visualize the dynamics. Because in metabolism, if we have something like glucose that enters a cell from our blood, glucose through a series of chemical reactions can be chemically transformed into a gas such as carbon dioxide. And so we really want to be able to visualize that in the network, where we start with something like glucose and produce a product like carbon dioxide. And so really one of our big tasks that's kind of coming up in sort of next term and through the summer is going to be to work on animations and enabling animations to run through the network. And then hopefully in the nearish future, we'll bring metabolism into the classroom and we'll be able to sort of assay learning impact and design some instructional resources as well. I think that's it for us.
Thank you so much, guys. Next, we have 3 projects, and these are from a course that EML is in collaboration with, Leader 399E, called Collaborative Prototyping. And we actually have Patrick here from Collaborative Prototyping to tell us a little bit more.
Thank you. Hi, welcome, 399E. I'm super excited to talk about this course a little bit and then introduce the amazing projects and amazing students who, half of the class is here today. So that makes me excited and super happy. So 399E, Collaborative Prototyping, is a pilot course run out of theater and film in collaboration with Emerging Media Lab. It in itself is a prototype. We're in the 2nd pilot of this. Yes, the students might not have realized it, but you are in an experiment. I'm sorry. Okay, so in any case, I want to, first of all, because I always forget this, and I don't know why, but you should just assume that, okay, so first of all, thanks to everyone. Okay, now I'll get specific. So thank you, first of all, to Artie Paul, who's here, Director of Engagement Services. Working with Saeed, executive producer, see I got your title right this time, of UBC Studios and Emerging Media Lab for actually really championing this course to move forward. So first, let's applaud them. Yeah, thank you. Because they never get applause and they deserve it. Okay, so what is the course about? You learn about different ways to collaborate, different levels of fidelity of a prototype. You learn about prototyping generally. You learn how to work with other people. You learn how to improve your collaborations over time, become more efficient. You learn how to scope and scale. Kind of, does this sound familiar to like typical EML projects, except we build it in. So everyone is learning this at the same time that they are tackling a problem to solve with a project brief. Now, these 3 project briefs we had were unique in that way. The first one was the team tapestry, and they'll talk through it in a moment. But that first project was about using an existing UBC tool and applying it to projects at the Emerging Media Lab to give users a different way to navigate those projects. Typically, you go to a website, you see a bunch of text and images, and you're like, oh, that looks cool, and you click on it, and it's kind of random where people, although there's research on where people look first and blah, blah, blah. But what we wanted to do was work with Stephen Barnes, Dr. Stephen Barnes, who is our principal and our client partner, and also Daniel, who was also acting as client through EML, in order to create a different type of user experience of navigating these projects. And that team will talk about it in a moment, so yay, that team. The second one has the complicated title that I haven't memorized of Remote Virtual Production Interactive Prototyping, which I kept calling the mocap team. But really, they are an intense team that has worked really hard and long hours with the client partner, Sawmill Motion Capture Studios and Derek Carter. And what they were experimenting on and trying to break was an existing in development live motion capture streaming to animation tool that was just debuted earlier this year in August at SIGGRAPH. So they're going to tell you of their accomplishments. Really awesome. And lastly, we have the UBC VR Paintball Experience, and they started the collaboration working with Yangos Hadjianis from Christ Immersive, who are becoming internationally known for having VR theaters. And the eventual intent may be to have this VR Paintball Experience, which will be unique to UBC, as they'll explain, to be integrated in a VR theater environment. But for now, it stands on its own. And so I'm proud of that, and I'm proud of the team and all of their work. So, without further ado, the teams. Did I thank everyone? Did I thank Catherine? Thanks, Catherine. Woohoo! Thanks, Daniel. Awesome. And thanks to all the client partners as well, to Derek, to Yangos, and to Daniel Stephen, or Stephen Daniels. Now, and thanks to Matthew. See, I'm trying to remember everybody. Are you introducing Team Tapestry, or am I? Or let's do it together. Let's do. Okay. Introducing
The Emerging Media Lab Tapestry team.
Sweet. That's your applause cue, everyone. Yeah. Awesome.
Hi, so we are the EML Tapestry team. We have 5 members. This is Seneca, Jessica, and I'm Kristen. And we also have 2 other members who weren't able to join us today, like Shania and Ali. And so, as you have read from the title, we are in very close collaboration with the EML at UBC. At the beginning of the semester, they presented us with the issue of needing an interactive, immersive way for different audiences to engage with all EML projects. And so to solve this issue, we used the prototyping tool Tapestry to build a web-based platform. And in our team, we have 2 UI UX designers, 2 content writers, and 1 project coordinator and communications lead. And we also worked with a lot of client partners, many members of the EML and other client partners, which helped us a lot during the process. So we are very grateful for them. And I will pass it on to Jessica.
So these are some pictures of our design process. So the first thing that we did was organize all of EML's projects into categories that are similar to UBC majors, and then we sort of like prototyped it on a whiteboard so that the whole team could be on the same page, as you can see on the 2 left pictures. And then on the furthest right is like a storyboard of like a scenario similar to Imagine Day, where EML would have a booth in person and they would be promoting what they do, and hence they would show our Tapestry page along with that. And then these pictures, so the first one on the left is a drawing in Procreate, just so that we could visualize what we would end up be doing on Tapestry, so that we wouldn't be overwhelmed by learning the tool, and also just so we had a goal in mind without just like learning like aimlessly. And then the following pictures is in the actual Tapestry tool, with everything laid out. And as time progressed with our user testing and feedback, the structure and the colors changed over time so that the information flow would be less overwhelming for the receiving user. And I will hand it over to Ali to show us our demo.
Welcome to Tapestry, a multimodal, nonlinear, interactive learning experience. This tapestry is filled with informational nodes about the University of British Columbia's Emerging Media Lab's current and past projects. The projects are sorted into their related subjects with additional information inside each one of them on the right way to get involved. Let's get started. When first arriving on the site, a welcome page pops up to instruct you on how to use our tapestry, and also provides users with more information about what tapestry is. Users will also notice the right sidebar, which contains further in-depth user instructions. Using Tapestry's zoomable features, one can easily zoom in and out and click and drag with their mouse pad. The depth meter in the top right corner allows users to view either all branches or none at all. Moving around the tapestry, one can easily find all the subjects listed, as well as their corresponding department color. The color-coded nodes help keep the tapestry organized and also engaging for interactors. Another feature on Tapestry is the search bar. I can easily type in the desired department and it will highlight it, making user navigation easier to follow. Now let's try clicking on a node. From the Life Science node, it lists 2 projects to discover, Fossil Finder and 3D Metabolism. Clicking on 3D Metabolism, users will receive an in-depth informational description, and from there can branch off to additional nodes. These additional nodes will explore the project's videos and past images. And that's how simple our users can navigate through our Emerging Media Lab's Tapestry tool. So what are you waiting for? Try it out for yourself.
And I will hand it over to Seneca.
So to optimize the outreach of our EML Tapestry, we reached out to EML's team, and Daniel was able to include the Tapestry information into their newsletter. And we also created a Canvas course and embedded the Fossil Finder demo tool in a Canvas course page to show how educators can integrate EML's tools into their courses to enhance learning for their students. Thank you so much for listening.
Thank you so much to the Tapestry team. It was really cool to see the projects and work there with 3DM. Next, we have a presentation from the Remote Virtual Production Interaction Prototyping team, or the MoCap team.
Sure. Okay. Hello, again. We are informally known as the Motion Capture team. And before we start, I'd like to ask each and every one of you to do something for me. When I say clap, please clap. No, just a singular clap will do. But this actually, instructions. Everybody has a different way of interpreting them. So I'm gonna say 3, 2, 1, clap, and everybody claps. And already it's so difficult, and we're all in the same physical location, in the same space. Now, can you imagine if you had 2 actors that were coordinating a clap, something as simple as a clap, and one of them was in Seattle, and one of them was in Toronto? It's immensely difficult, and that's what we were trying to tackle with our project. So I'll hand it off to Josh, who's gonna give us a project description, and then we're gonna watch a video documenting our process.
Thanks so much for that, Tanya. So imagine that you're an actor and you've been asked to give a live performance with someone who is remotely, someone who is in a completely different location. And for whatever reason, you're not able to be there with them in person. Maybe you got COVID, or maybe it's like a Monday morning, you just don't want to wake up so early for a commute. There's a number of reasons why you couldn't possibly be in the same space. So we want to provide an alternate solution for actors to be able to perform in a same virtual space, even if they're in remote locations. So our project's goal is to sort of understand the possibilities as well as the limitations of virtual production, being in the same virtual space as actors who are in completely different locations. So we have a video to demonstrate for you what we've done so far. And
the recent global pandemic, the inability to interact physically led us to explore if virtual interaction could be possible. The question we're asking is, can the power of performance capture technology be utilized to recreate virtual human interaction? Traditional motion capture is the most accurate form of capturing human movement. It requires a controlled environment. Inertial motion capture technology, however, although not as accurate, it is less costly and more user-friendly. With the support of the Emerging Media Lab and Sawmill Studios, we created a scene with two performers in separate locations appearing in the same virtual environment. Performer A is at the university wearing an inertial motion capture suit. Performer B is interacting at the motion capture studio wearing a traditional motion capture suit. We had to develop a queuing system to guide performers since they could not see the other's presence. Interaction 1.
3, 2, 1, punch!
Performer A started a countdown and raised their fist before calling out their punch to coordinate the actor's physical interactions and timing. Interaction 2.
Grab!
The basic problem was that we had no way of knowing the direction and positioning of the other performer. The solution was to apply floor markers so that movements could be consistently choreographed. Interaction 3.
Push! Slam.
Technical limitations of the motion capture systems and streaming data transmissions have to be mitigated. Performers are dependent on the viewing monitor for synchronization. Delayed reactions affect the execution and performance.
Go!
thank you.
Thank you so much to the mocap team for that hilarious video. Next, we will be hearing from the UBC VR paintball experience.
I just wanted to add, if you want to see the results of their efforts, those will be on the EML site soon. So that's the teaser to actually go and visit the website and check out the results of those scenes that you just saw played out. I am totally not trying to stall for the next. Oh, look!
Hello, everyone. My name's Landon. The rest of the team couldn't make it. So we don't have any slides that show the names, so I'll introduce them all verbally. We had Misha, who was our programmer. We had Jiho, who worked on 3D modeling and programming. We had Michelle, who was also a 3D modeler. We had Stephanie, who helped also and was support, and Nick, who was a 3D modeler and support. My job was that I worked on the framework for the VR, and also I was responsible for just general support and finding some 3D models. So what was the project? We were tasked with creating a VR space that was originally for a theater. It didn't quite end up that way, but we created a lobby framework that could be built upon. So the idea was to be able to capture the spirit of, oh, we actually have the slides. Perfect. Was to capture the spirit of UBC. So what landmarks or what objects do you notice at UBC that would represent the spirit of the university to you? So some of the things that we thought about were, of course, the Rose Garden, where people go to graduate during the warmer months. We thought of the cairn, which stands in the center of main mall and was colored by all the different departments. You can see all the colors that it's had before, generally for engineering, but I remember during my undergraduate, people would paint it purple for psychology, yellow for music, and it would be a competitive aspect of, the different departments and their interactions. So using Unity and Blender and Maya, we had to basically put together this space, which was interesting because none of the team had experience with Unity, and only 2 of us knew how to use the 3D modeling software. So the idea is that we wanted to have a dream-like UBC. If you were to dream and see UBC, what would you do? How would you interact with it? We also needed to have a gamified function, something that people could do cooperatively or competitively. So we put in a paintball. And the idea originally was to be able to paint the UBC sign, but then we evolved it as well. Unfortunately, we had to tone it back. But we put in the ability to be able to paint other users. So everybody has a player model that's represented by a Thunderbird, of course, the mascot. And they have on a white UBC shirt that you can paint with the paintball if you throw it at them. The reason why we chose to be able to use a paintball is because of course, the painting of the UBC Cairn, but also because of the snowball fights that UBC used to host, where different alumni would come, throw snowballs at each other, and it was just fun, memorable. So I'm going to go straight to the demo.
Hello and welcome to the UBC VR Lobby Space. The VR Lobby is an interactive hub space that users can visit and revisit en route to VR Eduverses. We tried to capture the spirit of UBC through static and interactive components within the environment. You begin your interactive experience by spawning in a circular park-like area that resembles much of the main mall on the UBC campus. This is an open but non-intimidating spawn point where users can get used to the controls, like left thumbstick to move, right thumbstick to turn, and allows you to get the time to freely interact with the environment. And on top of that, we have added many non-playable characters so that the campus doesn't feel very lonely. For instance, this Thunderbird is just chilling on the bench, while we turn over here and this Thunderbird is dancing away. How cute is that? On top of all of this, we have some normal assets that make the place feel very familiar, such as bikes, bike racks, benches, light poles that are nearly identical to the real ones on campus, like these colorful rose bushes, which borders the entire lobby space. Moving on, as the users walk forward, they are greeted by the centerpiece of the lobby experience, which is the UBC fountain. But there seems to be a UBC floating sign above it with paint splatters on it, which could imply that it's paintable, but we'll get to that later on in the experience. On each corner of the UBC fountain are rose bushes to signify the rose garden, as we've combined these two aspects to be the central piece of what UBC campus is known for. Scattered around the UBC lobby are many different types of trees to signify the various seasons you can encounter on campus. For example, cherry blossoms were used to represent spring, whereas maple trees were used to represent fall, and such forth. One key element of differentiation from our VR lobby space as opposed to a real-life campus is that you will notice these paint buckets with different colors on them. These colors on the banners and the buckets reflect faculty colors at UBC, which is a way to give a sense of identity to the users experiencing it. For instance, if you are a Faculty of Arts student, you will try to find your faculty color purple, whereas yellow is music, blue is for science, red is for engineering, and so on. We've added bubble particles on top of the paint buckets that grant affordance and captures various attentions. To grab a paintball with either hand, users can press the trigger button on either their left or right controllers. Now, if you drop the paintball, it will just create a large splash of paint on the floor, or better yet, maybe you could try throwing it at the UBC sign that we mentioned earlier. This is a fun little neat activity that you can do while having the lobby experience as a way to signify that you've left your quote-unquote mark on the VR space. This paintball idea was inspired by a combination of UBC's campus-wide snowball fight and the engineering Karen painting. Lastly, I want to mention that users can see the reconciliation pole, the must-green pole, and the clock tower. This layout of the environment is quite symmetrical, and the tall objects serve as landmarks but also helps out with the orientation. They are fenced off portions, which means that these could lead to other VR eduverses. With that in mind, this means that our project still stands as scalable. From all the trees, bushes, flowers, and landmarks that surround the nature of UBC, our VR experience feels like a timeless space. Thank you for joining us.
Thank you.
Thank you so much to the VR Paintball team. That concludes our presentations for today. We'd like to thank you so much for joining us today. If you're interested, there's a number of ways you can get involved at EML. For faculty members, you can submit a project proposal. If you have a great idea for something in the classroom, like that, something you've been inspired by that you've seen today or elsewhere, we are now accepting proposals for summer 2023. If you have questions or are interested, you can chat with us today or send us an email and we can set up a meeting time, emergingmedia.lab@ubc.ca, which you can find on our website. For students, we're currently seeking volunteers for the next school year, or you can join our student group, EMLX, where you can work on your own project using the resources that made our own projects at EML. Finally, you can take Theater 399E, collaborative prototyping. Today, you got to see just how much fun that course looks. I wish I was a UBC student, because I would be taking it. Thank you so very much for coming today and spending a little piece of your busy December with us. If you want more information, you can go to our website, eml.ubc.ca, or you can just ask anybody here because the whole team is here. We really appreciate everyone's support. We will now head over to the Dodson room to demo some of our amazing projects that we have today. Thank you so much again, and let's get over there now.